Hi everybody, welcome back. So what we're going to work on this time is on the SX-1980. We're going to work on the amplifier modules. And there's a couple of challenges because what I'm going to do on this is I am going to replace those original power transistors with a modern set of transistors that we can, at least at the time of this video, that you can still order. Now there are two types of transistors we can use. They're both very similar. One handles a little bit more power than the other, but other than that, either one will work fine. I'm going to show you both because I'm going to do one set in this receiver when I restore it, and then the next 1980 I'll use the other ones. Now the only thing is the ones we're going to use here present a little bit of a challenge, and I'll show that to you because they're a slightly larger case style. And we'll get into some of that here when we get onto the bench. But once we're done, we should be able to get both amplifiers put together, get them up attached to the receiver, and I may be able to get some power to this for the first time at the end of this video. So let's get started and see what happens. Okay, I just realized I talked for 10 minutes and I didn't hit the record button. So let's start this over again. These transistors, the original ones, 2SB706A for the PNPs, and they're like a blue color, and 2SD746A for the NPNs, and they're a gray color. They're both made by NEC. These were really high quality transistors in their day. They were in a very large package, large case, and this is not an MT200. There's a lot of 1980s amplifiers out there with transistors that looked like this, but they're ever so slightly smaller. And let me demonstrate. This is an MT200 heatsink pad. And if you look at the spacing between the holes and you look at the overall size of the pad, you can see that the pad is just slightly too small. I mean, it'll barely cover the transistor, but if you look at the mounting holes, they do not line up. And this is actually a wider case. So this is not an MT200 case. So if you damage those mica pads, you're going to be in trouble on these because you're going to have a hard time finding these. On the last 1980 that I did, I actually replaced the pads with sill pad material, Bergquist, really good stuff. But I had to buy it in sheet form, and then I had to cut it to the right size for these and then punch the holes because you just can't get these. The other thing is these transistors were only used in a few different devices. They were used in this amplifier. They may have been used in the 1280. I can't remember. They were used in the JCPenney MCS 3125. I think they just used 2 of them per channel in those. And they were used by Lowry Organ Company in one of the organ amplifiers. Strange, huh? But really, you didn't see these very many places other than that. They're unique in that they have 2 collector leads. So there's collector, base emitter, collector. You notice one of them they don't even use. They're electrically tied together, so they're just shorted together. That's to allow, number one, you have versatile pin out because you can have any pin configuration. And second of all, you can run 2 collector leads on here to kind of like share the amount of power from the wires, because this of course is going to be your feed coming in from your power supply, and then the emitter will go to your speaker, and then the base is your actual drive signal. Or another rumor I heard, which is only a rumor and I don't know if it's true, is that they also could use this for a circuit where you could actually connect like a Kelvin wire to this one, and you can actually measure the voltage drop on your power wires coming to it and compensate for that with your negative feedback. Now, I heard that. I don't know how true that is. I don't buy into that, but that was a rumor. Anyway, these are unicorns, and if they fail, you'll be in trouble trying to find a replacement. So what we're going to do is we're going to upgrade to a modern transistor that can be purchased today as of at least of this shooting of this video. And will make this last for many, many years, and these are a lot more robust. The cool thing about, I'm going to show you two different types of transistors you can use. Both of them are very similar specs to this as far as transition frequency, power rating, voltage and current rating, all that. So as far as the circuit board is concerned, this board will not know the difference between these transistors and the ones we're going to use. Okay, so let's start with the ones we're going to use in this amplifier, and then I'll show you a different set we will use on the next 1980 when I restore it. So the ones we'll be using for this is the MJL 4302AG, and those are the PNPs, and MJL 4281AGs. Now you notice these are good. These have 350 volt collector emitter breakdown voltage. They're good for 15 amps. They can dissipate 230 watts, whereas these ones are rated, I think, at 180 watts. So even though these are larger case and everything, these can actually dissipate more heat and handle more current than these ones. But these aren't just power transistors. They actually have a very high transition frequency similar to these. And that's really important for how the feedback loop will work on this amplifier. A lot of these big high power transistors you purchase today have very low transition frequency, like 3 or 4 megahertz. These ones I think are 30 megahertz or 15 megahertz, which is similar to what these are as well, which makes these kind of special. And again, these are not ring emitter transistors, nor are they LAPT process transistors. They're standard epitaxial process transistors, but they're high frequency. It made it these were very unique and very special in their day when they made them. And they still are today, because there's not a whole lot of these out there available that have those specs, but this is one of them. Now, they use what's called a TO3PL, and the L stands for long case style, or a TO247, I believe. And they look like this. So you can see they are slightly smaller than these, but they're a big transistor and they can handle quite a bit. The other option, and this is what we're going to use on the other receiver when we do it, is these ones are TO3P cases. And you notice how they are smaller. They are slightly smaller, a little bit shorter case. And these ones are the NJW1302G for the PNP and NJW3281G for the NPN. And notice instead of 230 watts, they're 200 watts. The transition frequency, all that is very similar to these. Okay, so these are just a higher power version of these. So you can pretty much use either one interchangeably because they both exceed the ratings of these transistors, so you're good. And plus, you're going to have 6 of those suckers per channel, and this is a 270 watt amp, but 270 watt amp with this kind of transistors and this size heatsink, way overkill. So these should run really well. Now, I can use a TO3PL mica pad, and see I have a pack of 1,000. You can buy these online. And I can use thermal paste and all that, which is messy and not my favorite thing to do, but it will work. Or I could use a high quality sill pad, and I have these MT200 sill pads, and they're really good quality. They're pliable, so they'll kind of squish in here and fill in all the nooks and crannies and mill marks of the transistor, surface, or the heatsink surface. And you can see how nicely they cover everything. It acts like, gives you some nice electrical insulation. So I'm going to use those because I have a bunch of them. And again, we don't need to do that, but that's what I'm going to do. Now, to make things even easier, you can get these boards online. Now, this is the older style, and I can't find these anywhere online anymore. And these are transistor adapter boards for the SX-1980, and there are right channel and left channel versions of this. And I don't really see a big difference other than the part numbers are a little bit different. GWH 110, GWH 109. But I think the orientation of the boards is the same. The other ones that you can buy today, it's $25 for a set of 4. You can get them on eBay. Just look up transistor adapter boards, Pioneer SX-1980, and you'll see them. And these are simpler looking, but I kind of like them. What they did is they moved the connections from going this direction to going this direction. See that? And other than that, they're pretty similar. They took the capacitor and they moved it over to here. They took the ground leads and so forth and the collector leads, and they flipped them over here on this version, where this one they were going this direction and the ground terminals right there. So some slight differences, but it's the same idea, and it will work. So I'll show you both of those being installed as well. When it's done, it's going to look something like this. There's what it looks like, and that's how they mount. And somewhere, I think I even have a picture of the heatsink before we put those boards on there. And that's what the transistors are supposed to look like. Now, they're showing them bent straight up like that, but you do not have enough space from here to here. If you bend these straight up, this board will come in contact because of the way it has to be in, base collector emitter. So I can't turn them around this way or they'll be backwards. So the only way they'll fit with the TO3 PLs is you have to put a double bend in them like this. So see how I did that? And then I just put a little bit of tubing down here in case they make contact with the board, which they won't. I don't care. I'm just being abundance of caution here. And you can see it'll mount just like this. And it will look really nice in there. See that? So that's the whole idea of it. Now, with these TO3P, which was the original transistors these boards were made for, you can just bend those leads straight up like they have in this picture here, and they will fit. You won't have any problems. So, just to give you a little idea of how this is all going to work. So let me get this wired up, and I'll show it all to you after it's done, and we'll see how it turns out. Okay, so as I said before, I've had these older boards for a long time, and they look kind of fancy, but I can see why they don't make them anymore. These are a bad design. If you look at the way they're made, the connections for these connectors are clear down here. As a result, when you try to line this up here, you don't have enough room to get this to plug on there. And that's going to be a big problem. When you look at this other one, they moved the connectors all the way over to here. So when you put this up in here like this, look how much further it moves these wires clear up to here. See that? So as a result, that gives you just enough extra space, because you can see I'm off by just about that much. See, it almost goes, but not quite. So I'm going to have to extend these wires, which really sucks. I hate that. But there's nothing I can do because these are a really crappy, defective design. So if you see these ones with this white screening on them, and you see the connectors that go here, do not buy them. Get the newer ones like this, where these are going to be up here on the end, and your cables will fit. Because these are really short cables when they're connected to the transistors. They just come right off the top of the transistor and come out. So that's going to be a problem. So I'm going to have to fix that. Okay, so after an unnecessary having to extend this because this thing wasn't, these boards are not correct, we're fixed now. So I guess that's why you don't see these online anymore. You can't find these ones anywhere, and that's why they were probably a bad design. And those other ones I showed you, I got those more recently for the other receiver. These ones I've had for quite some time, because this first SX-1980 has been sitting around for quite a while, waiting to get restored. So anyway, no harm, no foul. We got them replaced, and it's just extra work if you're going to use these ones if you have them. Now, when I put this on, this is going to go here like this. These are going to plug up onto here. And actually, once this board goes up on the other side where it belongs, these are going to pass out through this side, not here. So just so you know. Okay, as you can see, we have the right channel installed completely, and now I'm just finishing up the left channel. I have the boards mounted up, and I have my extensions on my wires, and they're installed. And I really do think that those other ones will not need to have an extension, just because these are clear up here on these ones. See that? So I'm hoping for that. That still kind of annoys me. But anyway, these are done. And now I just have to remove the power wires from here and get them transferred over here. The other thing I didn't like about this is there are two little wires here and then two big wires. And they show you on the diagram to stuff both of those wires in here and both of these wires in here, and they just don't fit. So what I did was I put one of each of these wires into here, and then the small wires I wrapped around the collector pin of one of these because they stick up pretty good, and tacked them in there. And I think that's a lot cleaner install than doing it the other way. Now I probably could have opened these up, but if I drill these out, these are plated through holes. I don't really want to drill out the plating. So I think that's the best option. That's what I'm doing. It's what I did on the other side. It looks good, so that's what I'm going to do on this side. Okay, as you can see, I have both of these modules installed and put together, and it is now the moment of truth. Now, I have never powered this thing up since I got it, because if you remember when we got this, the power supply board was burned up with bad components. The thing was a rusted mess, so I just stripped it. So massive amounts of work have been done to this, so there is very good possibility that there could be something wrong. You know, there could be some wiring faults or something that I did along the way, because we had to do so much to this thing I had to do. So what I'm going to do is I'm going to power this up pretty carefully. I'm going to start out by putting this thing on a 40-watt light bulb, dim bulb tester. So that's going to really limit the current a lot, but we don't care right now. All I really care about is not seeing any shorts. The other thing I'm going to do is I'm going to eliminate this board kind of from the circuit by removing all these fuses. So you can see there's no fuses in here. The only one that's in is the main fuse coming in from the power cord. And what that's going to do is that's going to power up the power transformer through the current limiting resistor. It will not allow this relay to come in to bypass it. So we have between the bulb and this, we have a lot of protection on this thing. And the only thing that will receive power, let's take a look at all this. So with all these fuses being out over here, what that's going to do is that's going to prevent all of this from turning on. So your plus and minus 100 volt supply, the 35 volt regulated supplies, the plus and minus 80 regulated supplies, all of this is going to be non-functional, which is what we want. And these two modules, you can see you have the two red wires and the two purple wires. Those are a separate set of windings, and those are for the big 80 volt power supply, which is what feeds the output transistors and so forth. So that's the high current supplies right here. those are the only two things that are going to come on. So what we're going to do is I will connect to ground. And when I turn this on, I should see the bulb come on really bright because those massive capacitors are going to start to charge up. But I should be able to go on these 10K bleeder resistors, which is the same as reading your plus and minus 80 volts for each side. And I should be able to see the voltage climbing up, and it'll go up to 80 volt. Well, it'll get up somewhat, but it will be limited by that bulb. You won't get the full 80 volts. If I see that, then I know there's no shorts, at least on the output section of these two modules, which is going to be good news. So now that I've kind of given you the scenario, I'm going to put this meter on right now, and hopefully we'll get it so you can see it. I think you can see there. And I'm going to turn the power on. I have my 40-watt bulb on, and it's on limit. And here we go. And that light is really bright, but it is dimming down pretty quickly. So I have, that's climbing up. That's the negative supply. That's the positive supply. And then here's the negative supply on this side, and the negative supply on this side. So you can see they're climbing right up. And they're climbing up equally. You notice those voltages are coming up about the same. And the bulb has now gone completely out, so that means the capacitors are fully charged. So I'm going to turn off the power now. And I'm going to just measure this, kind of watch it bleed down. And it's going to take some time through these little resistors. These are tiny resistors for bleeders. So they're going to take a long time to bring that down. Oh, I'm on the ground here. Yeah, it's coming down. It's just going to take time. So we can use our discharge unit. I'm going to do that now. I'm just going to use this one here. And I'm just going to discharge this. I'm going to touch ground. I'm going to touch one side here. Whoops, sorry. Bring that down. You can see it takes a little bit on these ones. Okay, so that one's gone. That should get this one gone. Okay, and then we're going to come over here. The same thing. See how different this is from discharging a vacuum tube amplifier capacitor, because those caps are so much smaller in capacity. Even though the voltage is higher, the capacitance is much lower. Okay, now that we know the big power supplies are working and there's no shorts, we're going to start going down the line here. Now, this one here, where's my pointer? This one here, fuse 5, this goes out and it feeds these lights. So you can see there's the transformer winding, goes on to 24 through the fuse and out to the lights. Now that fuse I have to leave out, because if you remember when I took the faceplate and everything out, I took the light bar out. The wires for the lights are just kind of dangling out there, and they can be shorting out to the chassis or something, so we don't want that to happen. So I'm going to leave that off. That's most likely going to work because there's not much to that circuit. Okay, the next thing we're going to put in is fuse 3 and fuse 4. These two right here, and you can see they're coming off of the transformer windings, and they go into these two diodes here, D203 and 204, and those create your plus 25 volt supply. All right, so looking at the schematic here, this is the European version. This part is different than the amp I have. The one that I have is wired like this, but this is harder to read. This part is going to be the same. This part is going to be different. This is what I have. This is what the European model will look like, but again, these are identical. It's easier to read this one. So there's fuse F3 and fuse 4, and there's those two diodes, and there's your 25 volts. They're saying 26 and 24, but we're calling that a 25 volt. So let's put those fuses in and see what kind of power we get with that. Okay, here's our two fuses, F3 and 4, and I have the meter connected to the junction of the cathodes of D203 and 204, so that should be our 25 volts, and it's going to be lower than 25, remember, because we have the dim bulb tester and everything. And hopefully we will see voltage there. All right, here we go. And that's climbing up. That's good. And the bulb is going dim. It's going really dim. And like I said, this isn't going to get all the way to 25, I don't think. It might get pretty close, but I don't think it's going to get all the way there. It might. Okay. Power off. So now I have it turned off, and you can see the capacitors are holding really well. So now let's go back in, and I'm going to bleed that off now. So we're going to go from ground to this junction. And those are smaller caps, so they bleed off really quickly. So let's get this out of the way. And let's bleed those giant filters down once again. Those are some really good capacitors there, those new ones. I go flip around here, make sure I don't short anything out. Okay. And that's it. Okay, so far so good, right? We have our voltages. Okay, next we're going to put these 1 amp fuses, fuse 1 and fuse 2. And again, those are going to come in with the orange wires. See, orange 1 and orange 2, they're coming in on TB3. You can see how they're connected here and here, coming in through here. And those are going to be rectified into your plus and minus 100 volt supplies. So this is a bridge rectifier here, and you're going to have positive and negative 100 volts. So that's going to be over here, these two here. So we'll get them snapped in. And let me get hooked up for some testing. Okay, now the meter is connected from the cathode of D201 to the anode of D206. So the differential between this, because we're looking across the whole enchilada here, we should see our 200, there should be 200 volts differential. Now it's not, I don't think it's, again, going to get up to a full 200, but it will probably get close to it. We'll see. And more importantly, I want to see that light bulb dimming down. And we may even hear the relay come in. I don't know. We'll see. So let's turn it on, and let's get our meter up here first of all, so you can see it. All right, here we go. And that one's got a short on it. See that? It's sitting at 6 volts and it's not changing, and it goes down pretty quickly. So there's a problem there. That's what that tells us. And that's the reason we have that little 40 watt bulb in there. So there's something wrong at our plus and minus 100. Now, we might be able to look at each side to ground to see if one side is dragging down, but I highly doubt it. Usually when this happens, it takes both sides down. So I'll check this one. Nope. Nothing happening there. And I'll go to this one. They're both doing it. So there's some hard short in there somewhere that's dragging it all down. Now we have to remember everything else is most likely charged up right now, so we're going to have to discharge everything again. Every time you work on this, you have to drain the capacitors. So I'm going to do that right now. You've seen the routine. I'm going to do that, and I'll be right back. Okay, so the first thing we want to do is we want to isolate this part of the power supply from the circuit over here. It could be something connected to the circuit, or it could be a miswiring problem in here somewhere. We don't know. But that whole line is fed by this little 1 watt 5.6 ohm resistor. So it just tells you how low current this whole circuit is. It's really not meant for current. It's just meant for reference voltages. And so I've lifted one leg of it, and you can see it's right here. I just pulled one leg up. And now I'm going to check and see. The only thing connected now is the 2 relays for the protect circuit. You see how those are all connected in there. So we should be able to see this thing turn on, hopefully. Because if it still does it, then that's going to be something right at the beginning of the power supply somewhere. So let's take a look. I'm going to plug this back in because I have a hard time getting the electrons to jump from the outlet to the prongs of the plug any other way. All right, here we go. Let's see what it does. And it's going up. How do you like that? Oh, you're not seeing a darn thing, are you? It's creeping up, although it's holding it down. So it's stopping at about 26 volts. Remember, it should be upwards of 200 volts, and that light is staying very, very bright. Now, I don't know why that is, but something is not happy in there. So we're going to have to dig into this a little bit deeper. Okay, the next thing I've removed is R212. I lifted one leg of that because that's the negative 100 volt side. That's this resistor right here. So now both sides are completely removed from the circuit, and I've disconnected P1 right here, which is what goes through the switch to switch in this relay here in case there's something here, although I don't think this is going to be a problem, but we're just going to see what we got. So let's go here. And let's turn it on and see what happens. And look, it's shooting up fast now. Look at that. That's what it's supposed to do. And the bulb is going dim. And that's just doing what it's supposed to. So it looks like the negative 100 volt supply side is where our problem is. And first things first, we have to bleed that down. And so we have a problem on the negative 100 volt line as far as I can see so far. So let's take that down, and then let's discharge these capacitors once again. And yeah, these are charging all the way up now. So it's definitely something on that 100 volt line. I'll bleed those down, and let me do this side. Very important every single time you do this, because you sure don't want to get across that big capacitor with, 80 volts. There's a 160 volt differential at a lot of amps on there. So you have to be careful with the voltages on this thing. Okay. So let's study the schematic a little bit and see if we can figure out why something's dragging down over here. I could have a component in backwards. Something connected to the output here, like the negative 30 volt supply. Something like that. There's also a negative 80 somewhere here. Any one of those things could be our problem. So we're going to have to just kind of go through it step by step and find out which part of this is failing. Okay, so now I've connected the positive 100 volt side back up and I've left the negative 100 volt side out. And we're going to see if this is directly on the negative 100 volt line. I'm pretty sure it's going to be, but let's see. If this voltage climbs up like it's supposed to, then I think we're going to be safe to say that that's where your problem is. So let's turn this on. And look at that, it's shooting right up. Look at that. And I have P1 connected, so we should hear, well, that's, yep, it just clicked. I am getting a little bit of extra current draw with that positive 100 connected, but this does go up. So it's definitely on the negative side, whatever our problem is. So let's bleed this all back down and start looking at that part. And you see, this is how you narrow a problem down. You have to divide and conquer when you're troubleshooting something. If you look at it as a whole circuit, sometimes it'll get overwhelming. But if you look at it as a bunch of individual circuits, you kind of separate all the different branches of the tree. It makes it a lot easier to narrow down very quickly what's going on. And I'll tell you, if I only have one little wiring problem or something after all this work, well, I'll be happy with that. Okay, whatever the problem is, it has to draw enough current to really pull that line down. So what I've done is I've disconnected this connector right here on the amplifier board on both sides. So I've done this plug on the other side as well. I've also reconnected, and I'll show you here, the R212 and R210. So everything's in circuit now. So all I've done is I've removed these two amplifier module plugs. If you look, well, if I can show you, here we go. If you look at these wires, this brown and red, same thing over here, brown and red, they go back to this connector right here. And that's your regulated 80 volts that the front end of each amplifier module requires. So let's just, everything else is connected except that. Let's see, I'm back across this 120 volt, or this 200 volts, you know, plus and minus 100 volts line. Let's see if it charges up now. Here we go. Okay, I have a really bright light, but that voltage is going up very quickly. See that? Okay, so the short is gone. And I just heard the relay kick in for the big capacitors. All right, I'm going to turn that off and let it drain down. Now the other thing I didn't pay attention to is, yes, all four of these green lights seem to be on. Well, they were on for a minute, and now they're off. They're probably off because we're not drawing any current right now, because it's not connected. And I just noticed something looking at that. I wonder if this has anything to do with it. You see something? I do. I didn't solder this diode in. That is D215. So let's see what D215 does. Let's see, there's a bunch. There's 214, there's 215 right there. I don't know that that would give us any problems, believe it or not. I don't know. I'll solder it in, but that's probably not the problem. I think it's on these amplifier modules, but we do have to touch that up. Let me bleed the caps down, and let me solder that, and I'll be right back. Okay, I soldered that in there, and I did verify it wasn't soldered the whole way through. I mean, sometimes when you solder it from the back of the board, it doesn't flow through to the top pad, but since it's plated through holes, it doesn't matter. But that one was actually not in there. But again, I don't think that's going to make any difference. Now what I've done was I plugged this side in, so this module is powered up. The other side I left unplugged. So let's see if we can isolate it between one amplifier module and the other. So everything's together. Let's turn it on and we should see this jump up again. And it does not. Look at that. Okay. And if I unplug this, like so, I'll take that out again, and I'll turn it on, and there it goes. Okay. All right. Now, I'm going to plug in I'm going to leave this one unplugged, and I'm going to plug this module in. And again, I'm staying away from the other module here, or I mean the other power supplies, because I haven't bled them down. I'm just going to plug this on real quickly here. Okay. Now this one's off, the other one's on, and it's working. Look at that. So there's a problem on this module here. That's what that tells us. And there you have it. So I'll have to take this off. There's only 4 screws and this whole thing opens up. It's actually pretty easy to get into. So let's open this up and take a look at why it may be doing that. Okay, hold the press here. Now first of all, everything is disconnected. There is no ground on this, nothing. The only physical connection between these transistors, this whole heatsink assembly, and the outside world there is the positive and the negative voltages. So these are the white wires are the bases from these transistors. They're all tied together. And then red, green, and yellow are all the emitters for each transistor. So you can see nothing's connected. I ohmed all these out. There are no shorts whatsoever. None. There's 0 shorts. However, when I turn this on, I have my probe connected, the negative lead connected to ground. I turn this on with nothing on here. Of course, I have my B plus going onto the NPN side, and I have my B minus going on to the PNP side. And you can see they're there with respect to ground. The emitter and base should have 0 volts because there is no path to ground through them, right? But if I check the emitter, I have 37 volts. And if I check the base, I have 37 volts. It doesn't make sense. If I go to the PNP side, though, really nothing there. I mean, that's just capacitance. You can see there's 0 volts. So there's nothing there. But on these ones, if I check the base, I have solid voltage on there. One of these transistors is shorted. Has to be. Brand new transistor. Brand new. And I've never put power to these transistors other than through this 40-watt bulb, which is absorbing the current of the big transformer and all the other circuitry in here. So there was never enough current available to damage these transistors. Here's what really gets interesting. If I go ahead and plug in this and I go to ohms, let me bleed these down first. And I look here. If I measure from collector where the voltage is coming in to the base, I don't have any shorts. You can see. And if I go to diode check, which puts a little bit more current to it, it reads a diode drop in one direction and no diode drop in the other. And they all three seem to be doing the same thing. And if I check the emitter, they all read like a normal transistor. Now the only thing I can figure is maybe there's something underneath the board that's shorting out that I don't see. But I looked underneath there, I kind of held up and looked underneath. I could not see any reason why it would be doing that. Especially with the fact that I can't read anything, any kind of short circuit from any wire to any wire in here. So this is an interesting thing. It seems like whatever the transistor is, it only seems to break down when there's voltage on it. And even without a path to ground, it's weird. I mean, the meter puts a tiny little burden on there, so if that's even enough to break down from the collector to the base and the emitter, one of these transistors is really bad. So I think the only thing I can do at this point is try to remove one transistor at a time and see if the problem goes away. Okay, as you can see, I've removed 2 of the 3 transistors, and I tested them on the transistor tester, and they both test good. No problems. One had a little tiny bit higher VBE than the other, but I don't think that means much of anything. Everything else looked pretty kosher there. So now we're down to 1 transistor on here, and I just want to see if the thing leaks. So there's our collector. That's good. Emitter, nothing, right? And then the base, nothing. So that transistor's good. So let's put one more in and see what happens here. Let's bleed the caps down, and then I'm going to put 1 transistor in at a time. Okay, now I put a second one in there. So now we have 2 transistors. Let's turn this on. And guess what? This one's leaking. Leaking like a sieve. It's bad. How about that? Okay, I removed this one and I swapped it with this other one. So we still have 2 transistors in there. Let's see if we still have our phantom voltages here. Well, they're not phantom because it loads things down. Nope. Look at that. So I have voltage on the collector. I do have voltage on the emitter. Oh boy, I have it everywhere. So it just seems like if I put 2 transistors in there, the problem comes back. Okay, back to 1 transistor again. Nothing. Nothing. And collector voltage. It's working again. Do I have 2 bad transistors? I don't know. Okay, I took this transistor out and swapped it with one of the ones that was making it do it, and it didn't make any difference. It works fine in that slot. So now I put a second transistor in this slot here and left this one open. Let's see if that makes any difference. And it appears as though it did. Nope, I'm getting something. No, that's just I think that's just noise. Nope, there's nothing there. Yeah, I'm getting something. 3.6 volts on the emitter there. Yeah, 3.6 volts. I don't know why it's doing that. But it's not getting anything out on the base. Huh. Isn't that strange? So I'm getting something there, but not a whole lot. It's a little bit of leakage. Okay, I found the problem. This capacitor is soldered in this board, and when they put that trace in there, it's so tiny. Let me see if I can zoom you in without losing focus. Right here, where this capacitor goes through here, the pad is so close to this trace that it's actually shorting onto this trace. Now this pad is supposed to connect over to this side, and you can see it goes up here and then comes down to the collector. So this is supposed to be connected to the collector. But if you look, it's also connected to the emitter, which means the emitter and collector are shorted together here. Now the weird thing is, when I tried to measure this with my in-circuit with the meter, it didn't measure. You saw that in diode check I wasn't getting that short, but obviously it's here. So it must be just so barely touching. This is an awful board. These boards are horrid compared to the newer one. I'm almost inclined to get rid of these boards. Now, I don't think we have the problem on the other ones. It's just this one that did it. If I go from here to here, and if I go from here to here, I don't have anything. See, it's wide open there. I mean, that's 500 mega ohms. I'm just picking up noise. So that one's not doing it. This one is. And I think this is just a badly printed board. So let me remove this capacitor and let's see what that does. Like that. I'll just take it out of here and clean this off, and I bet you the short's going to go away. What are the odds? So just remember, if you're going to get this upgrade and you see some of these boards floating around in the wild, don't buy these ones. Buy the newer ones. And you can clearly see there. Take a look at that. You can see where it's touching. It's just so close. So I'm going to have to clean that off with something. All right, you can definitely see that that board was printed incorrectly. Absolutely. Looking at the schematic, the collector should go to ground through that capacitor. And you can see by tying those together, oh my goodness, what a terrible thing. So let me fix that. I mean, I think that was a misprint because this board doesn't have that. None of the other three have that. And I mean, looking at the new style of these boards that you buy currently, if you look at the capacitors, there's all kinds of space in there. See how the cap goes in there? Much, much better design. I like that way better. So the other amp's going to get better boards, I think. Of course, these boards are fine, other than that misprint, that bad print on there. That should have been centered in between those two traces, and you can see it's not. So whoever did this did a really crappy job. I don't blame the company that printed it. I think it was just placed like that. Looking at this one here, it seems to have the same issue, although it's not touching. So I'm going to grind that out too, and I'm going to just surface mount that capacitor on the top. All right, let's see if we've achieved success. Nothing. Collector. And that's just noise there. That's going down. Yeah, see, they both do that. Okay. So I'm thinking that's working. All right, let's, and that could be right now because there's no emitter resistors, and the emitters and are tied together, or I mean the collectors are tied together and the bases are tied together on all of these transistors, and the emitters are open. And I think if you don't have, well matched, you'll get that little bit of phantom voltage there. But when we hook it up, that's all going to clear up. That fixed it. Okay, now the $64,000 question is, will our plus and minus regulated 80 volts come up now with everything connected? So let's see. And there it goes. It's working. Okay, so let's see what our midpoint is here. And you can see it's about a half a volt of, and I mean, this doesn't really matter because I'm not under full power or anything like that, but I just want to see if we can adjust the offset now. I can adjust it the wrong way. Oh yeah. That brings it right in. This is a 15 turn pot, so just to move it a little bit, you have to turn it a bunch of turns. All right. Okay. I think that means it's working. And my dim bulb has dropped way down, so we're not drawing excessive current, and amplifier is now working. Wow, what a wild goose chase that was. All right, we're all back together. Let's see if we have success. I now have the 100 watt bulb on, so that's going to allow this thing to charge up pretty well, but still give good protection to it if something goes wrong. Let's turn it on and see if we hear clicky clicky relays. I'm going to move the microphone down in here so we can hear things. I heard two sets of clicks. One was the soft start relay and the other one was the thing coming out of protect. And right now I'm on pin 32, or test point 32 there, and that is the DC offset adjustment with all the transistors in place. So let's go on to the DC balance pot. Let's see if we can't get this thing to come down. Oh, it's coming down nice. There we go. Okay, so we're down to 2 millivolts. And again, this will take 10 minutes to settle or so. And right now, we don't have full power on this thing either, if you recall. Okay, that's going to drift around a little while. And then on the other side, I want test point 17, which I think is this one right here. That's not too bad either. So let's turn that one and see if we can balance it, if I can get the tweaker on here. Hello, there we go. That doesn't look good. You see what that's doing on me? I think we have another shorted terminal on that board. I think I'm going to have to take that side apart too. I'm going to have to modify all 4 of these boards. See that? Okay, so looking at this side right here, there's all kinds of clearance on there. I mean, I can really see it in there. There is no problem here. These ones are physically centered between those 2 traces, unlike that other board. So I don't think this one is going to be a problem. So it could go back together. Matter of fact, I'm sure there's no problem here. So let's put this one back together and check the other one. Okay, so this one was also good. So whatever that jitter is, it's not being caused by that. So that's good. I can put this back together now, knowing that that's not the problem. Okay, so I put it all back together, powered it up, and I checked the bias. It's perfect. I was able to adjust it, and the bias on the other amplifier is good too. The other amp's solid now, but I still have this kind of noise. This is noise. You can see how it's kind of just jumping back and forth. It's not really going high. It's only going 100 millivolts up and down. And that's most likely a faulty transistor in here somewhere. So I'm going to have to trace that and see where we're getting that voltage jump. Usually when that happens, it's in the input pair somewhere. Noisy transistor or something like that. So little more troubleshooting yet. Okay, I think I have a faulty transistor, and I'll show you why. The unit's powered up, and first of all, that power supply underneath, that new power supply board, it has to have at least, around 110 volts, 107 into the mains, or the regulator for that 80 plus and minus 80 volt regulated will not work right. It gets real flaky. Now, traced it down to these 2 transistors here, which happen to be what are they? Q13 and Q15, which that's right in your bias spreader circuit. And I believe the one that's bad is this one up here, the current source transistor. And what's happening is, as it heats up, it starts to get shot noise, and it also starts to oscillate a little bit, and it drags down that 80 volt current regulated constant current power supply. So it causes all kind of problems. It even affects the other channel because the noise actually imposes itself onto the other channel because they share a common 80 volt supply. Now, just sitting here talking to you, you can see this is starting to jump a little bit, and I'll show you the scope in a minute. But if I put some heat on these 2 transistors, mainly this one here, you can see what happens. Now that's going to change because of the heat, but more importantly, what's happening over here is what's important. See that? And if I add some heat to it, it just gets worse. That shouldn't do that. It should just raise it. You shouldn't get that noise on there. It should just raise it up and down as it heats. Now if I take some of this freeze spray and spray that transistor, all the noise goes away and it's perfect. So I have a bad transistor in there. That's a brand new transistor also. It's just a faulty one. And you can see if once it starts to warm up, it'll start getting some noise on it. You see that? And then eventually you'll start getting shot noise. Now, it had really bad shot noise at first, But after I thermal cycled it by spraying freeze spray on it and heat on it a few times, the shot noise seems to have settled quite a bit. And I'm on DC coupling, so any little change in the bias would show up on there. But you can see just how bad that is. So I'm going to need to replace that transistor. That's a faulty one. So we had two faults. Neither one was me putting a component in wrong, which is great. But I had two defective components. One was one of those 4 transistor boards had the bad solder trace that was off-centered and shorting out. And the other one was I had put in a bad brand new transistor. So let me I'll probably replace the pair just for safe measure, and we'll see if this thing decides to settle itself down or not. Okay, so in typical Tony fashion, this turned out to be a wild goose chase. And it was not these 2 transistors here. I put them in, I replaced them with new ones, turned it on. It was 50 times worse. As a matter of fact, it went clear up to like 25 volts on one side. So I looked a little bit closer, and my first suspicion is what it ended up being, even though you saw where I sprayed these and it settled down. It's actually the input pair. And if I turn this on, you can see this thing goes crazy off center. See that? Look at that. It jumps all over the place. If you look at the scope, what's going on right now, you can see everything's kind of jumping around. And this voltage is all over. Watch if I just hit this even a little bit. And there it goes. It drops it. And now it comes back. And if I keep chilling it enough, it'll actually settle it down. So I'm going to probe this a little closer before I decide that this is exactly it, but that's where I am right now. Okay, more wild goose chase. I replaced this and the problem still was there. And what I found out was spraying this with chiller spray really wasn't doing anything. It was just a coincidence that I would spray it and it would move around. The other channel was really solid, and I noticed it started jumping around like that. And I said, something isn't making sense here. I mean, it just doesn't make sense. And you can see all while we're talking, this is staying within, several millivolts. And this hasn't warmed up yet, so this is going to drift a little bit, and then we'll recheck it. But what it turned out to be was I pulled these 2 links, and this is what connects the power amplifier to the preamp. And it appears, of course, I haven't restored the rest of this receiver. It appears as though either the flat amp or the tone amp or something has transistors with a lot of shot noise in them. Now, I'm pretty sure these SX-1980s have some of those 2SA726 transistors that are so notorious for having shot noise problems. And that was classic shot noise we were seeing when it would jump all over the place. So this tells us we're going to have to do a transistor replacement on the rest of the amp as well, because of all that shot noise. At least the 2SA726s and some of the other problematic ones. But you can see this is still holding. And I can adjust it very easily now and bring it right in. You can see, just moving this, I can just zero it right out. And of course it'll settle after I move it. There you go. That's what it should do. That's proper. And looking at the waveform on the scope, I mean, you can even go down to 20 millivolts per division. I mean, it's just, I'm looking at noise now pretty much on my scope, but you can see it's very, very stable now. So, long story short, there's more problems in this receiver, but it's not in the power amp or the power supply. So, well, I replaced some transistors that didn't need to be replaced, and kind of threw me on a little bit of a sidetrack because, again, I'd spray this with the chiller spray, and of course it would coincidentally settle down a little bit or jump more or whatever, and I'm like, wow, I'm making a difference. No, I wasn't. So let this be a lesson that you can't always rely on that. Everything's interconnected on these direct coupled amplifiers, and it can be very difficult to troubleshoot them when things like that happen. So we're going to end this video right here. All right, so off camera, I'm going to zoom out a little bit so you can't look up at my nose hairs. So off camera, I'm going to just let this run for a while and make sure everything is stable and working properly. I'm sure it will be now. Once everything's perfect, I'll put the amplifier together, and on the next video, we'll get started on the front end of this receiver, which obviously has bad transistors, the little small signal ones. Very common with these Pioneer receivers from this era. It just happens. So we'll get those swapped out. So for those of you who say, you know, don't replace the components, they don't wear out, there's a good example. And how many videos have you seen me in now where these transistors have done this? So I'm at the point now, at the age of these things, if you really want to make them reliable, replace all the little transistors, and really the capacitors wouldn't hurt to replace either. Now, I don't know how deep I'm going to get into the tuner other than an alignment, because people don't use tuners as much as they did in the past, because there's not as much out there you know, being broadcast on broadcast FM anymore, but we'll go through and do it. That's it for now. This is a long video, wasn't it? So until next time, I wish you all peace, joy, happiness, and good health in your lives, and we'll see you again soon. Take care, everybody.